Myself is Girish Rias, Assistant Professor, Department of Mechanical Engineering, Cambridge Institute of Technology, KR Bangalore. Next process is rolling. So you see, rolling is the a pulp deformation process or metal forming process. In rolling, the metal of larger size is passed in between the roller, having a gap. So the metal will be squeezed into the smaller size. So the size obtained after compression will be equal to the gap between the roller. Okay. So rolling involve compression. It will act direct compressive force on the workpiece material, thereby squeezing of material will take place into the lower diameter. Lower thickness. Okay. The rolling is defined as the process of plastically deforming metal by passing in between the roller. It's known as rolling. Here you see the metal block are usually a rectangular or square block is used to pass between the roller. Okay, when you pass the metal between the roller, a direct compressive force will be acted onto the metal. So thereby the thickness of the metal will be reduced. Okay. So it is also the mechanical or metal forming process involve direct compressive force on the workpiece material for reduction of the thickness. Okay, plastic deformation take place due to direct compressive force. The material is subjected to high compressive stresses from the squeezing action of the rolls and to surface shear stresses as a result of friction between the rolls and the metal. Okay, the material is coming out of the exit will be having reduction in thickness. Next you see the rolling of definition of rolling. Another diagram you see. So the production of sheet metal is given in the diagram. So here you use a set of roller. Okay. In the top you will be having two roller setup. In the bottom also you will be having two roller setup so that force applied on the material will be high. So the example is given of production of sheet with the help of roller. So metal is subjected to high compressive stresses as a result of friction between the rolls and metal surface. The deformation will be take place. See here, the terminology used in the rolling operation here, the raw material you taken. Okay, bloom is the raw material. The size is larger size material. You see on the top, the diagram is given. Bloom will be having larger cross-sectional area. So bloom will be reduced into billet. Okay. Then billet will be reduced into slab. It is not a slab. Okay. The slab will be passed in between the roller. Okay. So these are raw material. I referred as ingot also. Okay. Ash cast material primarily in the bloom shape. Bloom is the product of first breakdown of ingot. Cross sectional area is more than 230 centimeters square. Okay, it is having larger cross section area. Whatever the casted product will be there, the casting component is reformed into bloom shape first. Then bloom will be passed in between the roller. Okay, for further reducing into billet. Okay, so just it is raw material. Billet also the raw material only. Billet is the product obtained from further reducing by hot rolling. Cross sectional area is more than 40 into 40 square. The cross section between 40 square and 230 centimeter square is called as billet. Cross section more than 230 centimeter square is termed as bloom. Bloom will be larger cross section. First, in primary process, bloom is reduced into billet. Billet is further hot rolled into slab. Okay, slab is having cross sectional area greater than 100 centimeter square and width is greater than or equal to 2 into its thickness. Okay, slab width will be uh, 2 times more, greater than or more than 2 times of its thickness. First, you will reduce the casted component into slab. Okay, so before it will go to the component production of sheet metal. So rolling is used to produce sheet metal only. Okay, so with the help of series of roller, a larger cross-sectional or larger thickness component is reduced into a sheet of metal. You see mild steel sheet or aluminum sheet or uh, copper sheet. So many sheets are available in the market. That is the outcome of the rolling operation. Slab is further down into the plate. Plate thickness is more than 6 mm. You see plate slab is reduced into plate. Plate further reduced into sheet. Okay. Uh, thickness is less than 6 mm is called sheet. Okay, or sheet metal. Sheet metal is further reduced into strip by passing through the roller. Okay, this is about uh, reduction of raw material from bloom, billet and slab. The later slab will be reduced into plate, sheet and strip. Okay, this is stage by stage reduction of raw material. Initially, raw material is in the form of bloom. That bloom will be reduced into billet, then slab, then plate, then it is sheet and then it is strip. Okay, so here again the same slide. Okay, ingots may be in the form of bloom, billet or slab. Okay, all three terms are considered as ingot only. So ingots are readily available in the market. In the second stage, you will obtain billets, plate and sheet. Okay, then it is converted into strip. See here, next rolling is classified into two types based on the working temperature, hot rolling and cold rolling. Generally, here you see there are different stage by stage reduction from bloom to billet, billet to slab, slab to plate. Until the plate, the reduction from bloom to billet, billet to slab, slab to plate, hot rolling process will be used where the maximum reduction of thickness will be take place. Then from plate to sheet, sheet is the final product. Most of the time, either sheet or strip will be final product. In that case, you will go for cold rolling because at the end, at the finishing stage, you require good surface finish onto the surface of the sheet also. Okay, reduction from plate to sheet and sheet to strip will be carried out by cold rolling. Reduction from bloom to billet, billet to slab, slab to plate is carried out by hot rolling process. Hot rolling involves maximum reduction of thickness. Cold rolling involves finishing operation. In order to finish the produced sheet or produced slab, what minimum reduction in thickness will apply more forces. What happened? The brittleness of the component made it to break. Okay. See, hot rolling involves the initial breakdown of the ingot into blooms and billets is generally done by hot rolling. As I told you, the initial breakdown of the cast component into blooms, then billet, then slab is carried out by hot rolling process. The cold rolling of a metal has played a major role in the industry by providing sheet or strip or foil with a good surface finish. For finishing touch, you go for cold rolling. For maximum reduction of thickness, you go for hot rolling. Okay. You see hot rolling strips is shown in the upper diagram. Lower diagram show the cold forging series of roller will be provided where you see the sheet metal is flowing on the uh, conveyor. on the channel only, there you will be having different setup of roller. Roller will apply the force. Because of the cold rolling, strain hardening will take place. As a result of strain hardening, the material property also enhanced. So you have to understand, hard rolling is carried out for maximum reduction of thickness from bloom to ingots, ingots from bloom to billet, and billet to slab. For this type of reduction, you go for hard rolling where maximum reduction is take place. Okay, cold rolling only for finishing touch from slab to plate or plate to strip, where you have to get a final component. So in order to enhance the mechanical property as well as surface finish, you go for cold rolling. Okay, cold rolling will give good surface finish. See, the initial breakdown ingots into blooms and billet is generally done by hot rolling, and then cold rolling is done to get a good surface finish and close control over dimension. So here, hot rolling occurs above recrystallization temperature. As we know, generally any metal forming process take place above recrystallization temperature is called as hot uh, working process. Here, hot rolling also above the recrystallization temperature. You see the left side diagram. So where the hot rolling is taking place. Okay, between the roller, a component is coming out of the material, out of the roller. Original coarse grain structure will be having growth of new grain, fine grains will be obtained. Okay, equiaxed grains as the material coming away from the roller. Okay, so the cooling will take place. The heated the material is above the recrystallization temperature before it enter into the roller. Once it is moving away, far away from the roller, the temperature will drop down because of it is exposed to the atmosphere. It will drop down. As a result of drop down of temperature, uh, grain structure will changes. We'll see in the next slide. You see, near to the roller, at the exit near to the roller, deformed elongated grains will be obtained. Further movement of the component away from the roller, where it is interacted with the atmospheric air, further reduction of temperature will be take place. The grain again re-alter into the new shape. Recrystallization complete. Okay, here hot rolling is used mainly to produce sheet metal or simple cross sections such as rail tracks. Okay, it will reduce the average grain size of a metal. This improve the strength of the material. So average grain structure of a metal will be reduced. So here you see in hot rolling, after reduction of initially the hot rolling, you see at the entry, the grain size will be large. As it reduced, the grains, the circular grains will be flattened as it comes out of the exit of the die, exit of the roller, it will flatten. Further movement of the material, the grain will be reduced to smaller grains. The recrystallization take place again because of force. Reduction of grain into a fine size will take place in hot rolling. Okay, so initially the grain size is large. That based on the thickness, the reduction of the grains into the fine size, and thereby uh, ductility remains in the material in hot rolling. Okay, result of hot rolling enhance the mechanical property by keeping ductile property intact in the material. Okay, there is no strain hardening effect. Okay, brittleness is not induced in the hot rolling process. Next, cold rolling process. Here you see cold rolling form is shown here. Okay, the right side you see cold rolled sheet will be wounded on the wheel. See here, cold rolling is used to produce sheet and strip with superior surface finish and dimensional tolerance. As we discussed, hot rolling is used to reduce the blooms and billet into the slab. Okay, thereby Further, in cold rolling, slab is taken and it will convert into sheet and strip. It is used to produce sheet and strip with superior surface finish and dimensional tolerance. Okay, dimensional accuracy is also high and surface finish is also high because of cold rolling. Also, the strain hardening result from the cold rolling may use it to give increase the strength because of strain hardening. So the hardness will be induced in the material. When the material is brittle, see the strength is also high. Brittle material is having high strength compared to the ductile material. Okay, but without any indication, it will failure. Okay, so brittle material is having because of induced brittleness, strength of the component will be increases. Total reduction achieved will be vary from 50 to 90% only. Okay, you can reduce the thickness only 50 to maximum reduction is say from 4 mm to 2 mm you can reduce. Okay, further reduction is not possible in cold working, whereas in hot working you can reduce a 10 mm into 2 mm directly, where the percentage reduction will be somewhat what 10% you can reduce, 10 mm into 1 mm you can reduce. Okay, in hot rolling, whereas in cold rolling the maximum percentage reduction is 50 or 90, 50 to 90% reduction only possible. And lower the percentage reduction, enhance the surface finish also here. So cold forging is usually cold rolling operation is usually carried out in room temperature only. The broom reduced into the billet. Okay, once the bloom exit out of the roller, further heating chamber is provided. Further, it will go above the recrystallization temperature. The billet will enter into the second series of roller. The billet will reduce into slab. Further, slab will be heated and it will go to the next series of roller. Slab is reduced into sheet. Once the sheet is obtained, for further reduction, use cold roller. Up to that, use hot rolling only. It is a usually the sheet production is carried out is continuous casting process. The component coming out of the casting taken into the series of roller up to the reduction of into the plate size or slab size, hot rolling will be carried out. During final touch, final finishing operation, cold rolling will be carried out. We will get a good surface finish. You see, the result of grain in cold forging, as we see in hot forging, hot rolling, fine grains will be obtained at the end of the product. Okay, grain will be elongated, then new grains will be forming, then recrystallization take place because of forces and temperature. So grain reduction into the finer extent. Here you see elongated grains will be obtained, strain hardening will take place. Okay, you will not get a finer grain. If you get a finer grain, then ductile property present in the material. If you not get a finer grain, if you get a elongated grain, so that brittleness will be present on the material. Cold rolling induce brittleness in the material. So that's why sheet metal will be having ductile property also. So at the final only you will try to finish the surface rather than reduce the thickness. If you try to reduce the thickness, the brittleness is induced. Okay, in order to avoid that induced brittleness, up to smaller size reduction is taken by hot rolling only. Because of that hot rolling, keep the ductility property in the material. Okay, for only finishing, cold rolling will be used. As we know, cold rolling is only used for finishing, not for uh, reduction of thickness as in case of hot rolling. This process increase strength up to 20% via strain hardening. Cold rolling increase the strength 20% via strain hardening. Okay, so then the maximum thickness reduction in one pass is equal to static friction coefficient between the rolls and metal. Okay, friction coefficient between rolls and metal and radius of the rolls. That will give maximum reduction of thickness without any cracks can be obtained by this H max formula. H max is equal to mu square into R. Difference between hot rolling and cold rolling. Blowholes and porosity eliminates by welding together. In hot rolling, any blowholes and porosity is there, it will be eliminated by welding together because of compressive force. The welding of the blowholes and porosity take place. Then here in cold rolling, increases strength. This will result into better ductility and toughness. Hot rolling result in better ductility and toughness in the material. A cold rolling strength will be increases and dimensional control will be more. You will be having good surface finish in cold rolling, and ductility will be decreases in cold rolling. Surface decarburation of the steel will take place because hot rolling it is subjected to environmental condition also, that will result in surface decarburation. Scale formation also take place in hot rolling. Here no such problem in cold rolling. In hot rolling you will not get a good surface finish. Dimensional tolerance due to expansion and contraction of metal will be less. Okay, so dimension accuracy is less in hot rolling. In cold rolling it is high.